let's talk about quartiles. Now, a quartile is a measure of a location in a list in Q1, Q2, and Q3. So we have three quartiles. Q1 is the first quartile, and it is equal to P25, the 25th percentile. And Q2, of course, is the second quartile, and it's equal to P50, which is also equal to the median, which is X tilde. And then Q3, of course, third quartile, and that is equal to P75. So we've got this about 25% here, divided into four groups with about 25%, because as we have with percentiles, there's not necessarily a established, agreed upon universal process for computing these things. If you don't have a number of values that evenly divides into fourths, then your 25th percentile, or your first quartile, isn't necessarily going to fall exactly at a whole number item in the list, and so we have to round, and different statisticians have different methods for doing that. We're going to stick with this basic process that we've used before for finding percentile. If we want to find a certain percentile, we will use this, figure out where we're supposed to go. So using this, if I'm trying to find the kth percentile, I take k over 100, oops, k over 100 times n. And so let's look at an example here with a list. If we take this list of class heights as an example, we want to know what's the first quartile. Then we say Q1. We want to know the 25th percentile, and so we say, first of all, we're going to find this number L, which is 25 over 100 times n, again using this process right here. And then we look at if that L turns out to be a whole number, and we round it or not. Okay, well in this case, n, there are 28 items in this list, so 25 over 100 times 28 turns out to be a nice round number. It turns out to be 7. So in this case, since it is a whole number, according to the process here, if it's a whole number, then the value of the kth percentile is midway between the Lth value and the next value in the sorted list. Okay, so the seventh value, we've got 1, 2, 3, 4, 5, 6, 7. The seventh value is 66. Since L is a whole number, the flowchart, this flowchart right there, tells us that P25, which is Q1, is midway between the third item, or the seventh item and the eighth item. The seventh and eighth items in the sorted list. Obviously, if the list is not in order, then this doesn't do us any good. So it needs to be in a sorted list. So the seventh item is 66. The eighth item is also 66. Well, what's midway between 66? We take 66 plus 66 divided by 2, and let's see, get our calculator. What do we get? Yeah, 66. It's just the average of those two values. That's all it is. And of course, when they're the same, that's even easier. 66, that's Q1. Done. Now Q2, again, we're dealing with whole numbers here. So Q2 here, we can already tell it's going to be 50 over 100 times 28, which is going to be 14. And so find the 14th item. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 14th item was 69. The 15th item is also 69. So, well, that's perfectly consistent with what we used for median. Since this list has 28 items, when we calculated median, we said if a list has an even number of items, then the median will be midway between the middle two values. And that's exactly what this flowchart is telling us to do. When it turns out to be a whole number, it's the same thing. We take between the 14th and 15th values, because otherwise, if we just took the 14th value, we would be using this one. Okay, again, in this case, 69 and 69, the value between them happens to also be 69, but we can see that if I had an even list of numbers, the median shouldn't be one of those values. If the sample size is even, then our, oh my gosh. Ridiculous. If the sample size is even, then the median should be between those two middle values. And this process with the flowchart gives us the same thing for Q2. So Q2 ends up being 69, because that happens to be what's between these two values. And then Q3, well, again, we take this, it'll be 75 over 100 times 28, which ends up being 21. And so we have from the 21st value. This is 14, 15, 16, 17, 18, 19, 20, 21. 21st value is 71. So according to the flowchart, since L, which is 75 over 100 times 28, happens to be a whole number, we are supposed to take that number between that one and the next one. So the midway between 71 and 73, and we get 72. Okay. So we see that Q3 is not actually one of our values. Well, we saw the same thing with our median. The median isn't necessarily one of the values if it's halfway between those two middle numbers. But we can also look at this little visual here. Once we found our medians, or our quartiles, these quartiles do break the values up. 66 has 1, 2, 3, 4, 5, 6, 7 of those values, and then 7 in between, and then 7 between, and then 7 after the last one. A little harder to see with that 66 and that 69, but we can see it with the 72. There are exactly 7 values above 72. And exactly 21 values below Q3. So Q3 perfectly divides this, 72 perfectly divides this into 75% below and 25% above. The 69, you could say that there are actually only 13 values below 69, because 68 is the 13th value, and so on. But again, we get repeated values like that. That's why it's about 25%. There you go, because some of these things are just unavoidable. Okay, when we put these things together, we get something called the 5-number summary, which is the minimum value, Q1, Q2, which is also known as the median, Q3, and the max.